Hello, good afternoon all. We will wait just a few more minutes for others to join and we'll start our today's session. Okay, so good afternoon all once again. Today we are going to have hand-on session. So in our so far previous session, we went through different things in PIC18 architecture. We went through our architecture of PIC18, we went through pin configuration, we went through the special function registers, SFRs, we went through memory organization, we went through instructions, and so many things. So today we'll see how actually this everything happens actually through a practical. So today complete session will be based on this practical. Of course, many of you don't have any PC or laptop with you so that you can work simultaneously. So I'm not expecting you to work simultaneously. What I want everyone of you to please make a note of all the things which I tell you here. Okay. So please have a book with you and make a note of it. Okay. So the for practical purpose, the software which we are going to use, that is simulator which we are going to use, is MPLAB IDE. MPLAB is for specially for microchip. It is specially for microchip microcontrollers. So we are going to use this particular simulator, MPLAB IDE. Here I am using 8.9 version 8.91. There are many other versions available. 8.92 is also available, but here I will be using version 8.91. Okay. How to get this? It is free of cost. It is provided by Microchip and it is free of cost. And you can just search for MPLAB IDE and you will get the link. Okay. Download link. You just download it It comes in a zip format. Unzip it, then you will find a setup file. Uh, just click on that setup file and go through the instructions and agreements and accept those agreements and follow the instructions. The this simulator will get installed on your PC. Now, after installing the simulator, then when you open the simulator MPLAB, this is what is shown. Okay, you have two windows. One is called untitled, another one is output. Then there are so many tabs. I hope this is visible to all of you. Is it visible? And Nico, I am audible.
Yes, sir.
Okay, so so we are going to use this MP lab. So first we are going to sort out or have a clear understanding of all the things that we went through. Okay, so the first thing you have to do is you need to click on project and project wizard. So project wizard will guide us to actually set up the project. So here you can see the first step is to select the device. So you can select any PIC device here listed here. And because we are going through PIC18, you can select any PIC18 device. So you can have here, you can see that there are many PIC devices. Even you have PIC16, PIC 12, PIC 16, PIC 18, and even PIC 24 and 36 also, that is advanced PIC. So PIC 24, and even we have PIC 32 also, which are advanced. But we will select PIC 18, and in most of our we took while discussing about architecture, while discussing about pin diagram, we took PIC 18452. So we'll select that only, PIC 18F 452. Okay. So once we selected that, it will ask for the compiler which we want to use. Mm, I think something went wrong. Let me do. Okay, yeah. So it will ask for a compiler and assembler which we want to use. Here we are going to use assembly language, so we don't require any advanced assembler. So we are going to select the basic, which is the first one here. Okay, MPASM, that is assembler. Okay, and we can click next. Then we need to create the project file. So just to click on browse. I prefer everyone to create a new folder. Okay, give it a name. Let me name to the project, and you can give the name. Okay, then click next. So here you have nothing to add at this time. So just click next and then click finish. So now you have this project here, and there are many files here. Don't worry about these files. The thing is, uh, whenever we need to write a program, we need a editor to write a program. Here is a output. So at present we don't have any outputs to be displayed, so this output is blank. Okay, so first we need to have a uh, file where we can write the program. So you can just click on this new file, or you can go to file and click on new. Okay, so this will open, and then the first thing you need to do is you need to save it. Save as, let me go to my project directory, that is session 1 here, and I will give it a name. .asm. It is because we are writing in assembly language, so asm.asm has to be followed, and save it. Directly don't try to write the program here itself. What happens is, let me show you. Let me write an instruction, MOV LW, that is literal with working register 0. Okay, and what we need to do is, you can see here in our project, this file is not showing practical1.asm. So we need to add this practical1.asm into this project files. So for that, click on file, click on add new file to project. So when you click on add new file to project, it will show this particular file which we have created now, practical1.asm, and you select that and click on uh, save. So it will tell to overwrite. Click on OK. So it gets overwrite. The problem is the program which you wrote will get erased. So after, that's why what I said is, after you add the file, then only start writing the program. Do not start before it, because it will be just waste of energy doing it before. Again, you need to type it again, because after adding, it will just erase everything. So you need to just first add the file, then type the program. Okay. So we will start with a simple program, and we will first verify the concept which we have learned so far in PIC18. So what concept we have learned? Let's see that. Okay. So let's say we are going to have load a literal into working register, that is MOV LW. Then we will move this to a file register. Okay. So with file register address, let's say 24. Okay. Just two lines of code. First, we will understand this, uh, how this works, as well as what are this actual meaning of this. Okay. So next, after writing the program, save it. Just click on file and click save workspace, or else you can even click this save button here. Okay. So once you save that, now what we need to do is, we need to build it. So here it is there. This icon is for build all. Okay. So just click on this build all. It will ask whether you want it absolute or relocatable. So when we choose relocatable, it means the code can be relocated to any part of the program memory. So to relocate the code, you need to supply the labels, all the labels required for relocating the program. But when you choose absolute, there is no requirement of supplying the labels. So here we will have absolute, because we are not giving any labels to the this particular program. So click on absolute, and this happens. Okay. So there is one error. Let me see that. Expected end. Yes, of course. It's my bad. Uh, Always the program has to be completed with a end. Okay. So now you can see that there are no errors. There are few warnings, of course. Doesn't matter. It doesn't matter about the warnings. So just leave it. And it also says that build succeeded. Okay. Now what we want is, we need to check the output. For that, what we want is, we need special function registers and memory locations also. So click on view. In view, you will have this file registers. So here data memory is called as file registers. So click on file registers. This file registers block will get opened. Then click on again view, and click on special function registers. So you will get the list of all the special function registers which we discussed in our registers section. Okay. Register session, we have discussed about this, all some of this, not all, but some of these special function registers. So we are working with working register, so please relocate it to working register. So here you can see working register, WREG. Okay, this one. So wreg is 00 now. So now we can see how this instruction will actually work. So to execute this instruction, you need to, of course, select a debugger. So select tool and select MPLAB SIM simulation. So because we are doing simulation, that's why we are selecting MPLAB SIM. Okay. So click on this MPLAB SIM. Here new icons will be popping up, and this icons helps in executing the code. Okay. So executing, the first one is step into. So it is just step-by-step execution. So if you click this, all instruction will be executed at a time, and you won't understand what is happening. But step-by-step in this execution, you will understand what is actually going on. So if you click on first instruction, so here first instruction is executed, and here you can see that working register is now converted to 0x34, that is hexadecimal 34. Okay, then what we are trying to do, we are trying to store, copy this 34 into a data memory location 24. So here what I mean to say is, here 24 is not an data, it's a address. Okay, so if you click next, executing next instruction, you can see that here we have 20 and here 4. So it is 24. At that location, data is changed to 34. So 34 from working register is copied into this particular address location, which is 24, which we specified here. Okay. So this tells us what actually happening. Now let's see what happens if we use BSR, that is bank select register. Okay. So I am going to include one more instruction, that is MOV-LB, and I'm going to change the bank select to third bank. Okay. Now let's see what will happen. Okay, built it. Again, no errors, build succeeded, so no problem. And we'll start the executing. Let me change. Let me clear this data. Okay, now this data is cleared, so there won't be any confusion. Okay, so you execute. First, we get working register 34. Okay, working register 34. Then, so here you can see that this BSR. So here there is BSR became 03. Okay. So BSR register, now we have stored it 03. Now, so here you can see that moved up 0x24. Again 24 address, we got 34. No difference in it. Okay. Because why? Because by default A will be 0. Access bit will be 0. Now let's say that we want to convert this access bit to 1. And now we will see what happens. Okay. Let me again change it 0. Okay. Let me change BSR also 0. And as well as working register also 00. Okay. Now everything is changed. So now let's start the step-by-step execution. Okay. So again, build succeeded. So first step, uh, working register 34 we got. Then second step, BSR 03. Okay. Now when you execute, you can see here that 24 is not changed. Why it is not changed? Because now access bit is 1. So we are going to consider BSR in the address. So the new address is now BSR has 3. So the new address is, that is 3 and 24. That is 324. So we need to go to 320, and at that time at that place 24. Okay, let's check that. So 324. Okay, so here you can see 320 and this is 4. So at this intersection we have 34. Got it? So this is how BSR work. Okay. So when we have this access bit set to 1, at that time only BSR will be used for calculating the address of the data. If that bit is 0, then that particular address will not get calculated. Okay, so this BSR will be not used to calculate the address. So this is what makes it different. So you can have either bit set to 1 if you are using other than Access Bank, other bank, uh, bank 1, 2, 3, and so on. Then you have to set this bit as 1. Otherwise, you have to not worry about this bit because by default this bit will be 0. Okay. So any doubts in this so far? Any doubts? I think you all are noting this down. I hope everyone is noting this down. Okay. So I hope everyone understood working this access bit. Okay. Now let's see the another, that is the destination bit, D bit. Okay. So for destination bit, we'll use another instruction, MOVF. Okay. So MOVF has instruction has we need to give the address. Okay, and then also we need to specify the destination. Let's say destination 0, you can specify destination 0. Okay, save it, I will build it. So again, no errors, come back again. Now when you execute, so now BSR doesn't matter, and because it is 0, MOVF 24 comma 0. So 0, what it does, it will move the content of register F into working register, because content of the address F which is given here 24, that is 24 is 0. That's why working register is cleared. You can verify by giving a another, by storing another number. Let's say 56 here. Okay, again let me execute again from start. For that again I need to build, then execute. So you can see first working register has 34, but when we execute that it became 56 because 56 is stored here at address 24. Okay, now what happens if I convert this bit to, let's see what happens if we convert it to 1. So first working register is now 34. Now when you do WF MOVF 0x24, what it means that content of the register 24 will be stored in 24 itself. So practically it is not doing anything. So working register will be 34 itself. Okay. So if you execute, you can see working register is 34 as well as the 24 address content is also not changed. So that is what destination bit does. So destination bit is very much useful when we are doing is addition. Okay, so let me do that. WF is the instruction. So here you will see the difference. So what actually we are doing is we are adding 34 with 24. So answer will be 58. So let's see where 58 will be stored. So when this bit is 1, the 58 is stored at which place? So 34 here and 56 here. And when you execute this, you see 24 address. 8A is stored. So 34 plus 24 gave us 8A. Why 8A? No, maybe some mistake in addition. Okay, hexadecimal number 34 and 24. So we got a result as 8A. Okay, so 8A result and working register is not changed. Okay, now let's see what happens if we convert it. So when you convert it into 0, now you can see uh, 80, I don't want 80 here, 56 was. So let's keep it 56 itself. So when you add it, so now you can see 8A is stored in working register, not in the registered bank. Okay. So that is the difference. The destination bit 0 and 1 dictates where the result will be stored, whether it will be stored in working register or whether it will be stored in the location which we are specifying here. Okay. Of course, with this, you can also specify the access bank also, whether you are going to use only Axis Bank or you are going to use other bank. Okay, by giving one or another thing is it is so this is how it is done. Any doubts in this? Please do reply so that I understand that you are actually getting to know what is happening. If you want, you can reply on chat box also. No problem. Okay, so it's clear now, right? Good. Okay. Okay, then we will move with a little bit complicated problems. Okay. Let's say that we will just add number 3 10 times. Okay. Let's say add number 3. Okay. So for addition purpose, that is repeated addition, and that is also the same number. Okay. So for that, first what we will do is, okay. So first let me clear everything. So let me make everything serious. Now we will write here the program. So let's say that we need a counter here to count 10 times. Okay. So let us define a counter. Zero. We need to give address where you want to store the count. So let's give it as 30. Okay. So this is the address of where you want to store the count. It is not the count value. Okay. So at 30, address 30, the value of the counter will be stored. Okay. Now we will start the program. First we will load working register with the count value, that is our You can either specify in hexadecimal like that. If you want to do it in decimal, you can specify using D. D quote, specify decimal number and end it with quote. So this gives us decimal number. So you can specify decimal number like this, or you can even specify hexadecimal number like 0x0A. Okay. Then we will move this to our destination, that is at 30, which is given by counter. Okay. So here specified, you have specified this counter as a address 30. So whenever we are using counter, it will go for address 30. So after that, let me now clear, let me have 3, because we need to add 3 every time. So first let me clear this working register. Okay. Now we need it repeatedly, so we need to create a label. So this again is label here. Okay, it is a label to specify that we need to again and again loop it to again. So here we will have add, and we are going to add 3 directly. Then we need to decrement the counter, and then we can use the zero flag to check whether the counter is zero. But the zero flag will be directly can be checked here. Okay, so decrement file register with uh, skip 0. Okay, if the after decrement, if the value is 0, then the next instruction will be skipped. Otherwise, it won't get skipped. So what we want to decrement here, of course, counter we want to decrement, and we want to store the result in counter itself. Okay, we don't want it in working register. That's why give it 1, comma 1. Then uh, we need to just jump. Hello, any doubts, anyone?
Sir, your mic actually turns off and turns on automatically.
Automatically. Might be due to internet connection it is happening. But is it audible clearly, or do you have some disturbance in it?
It is audible, but sometimes it goes slow and
Okay.
then.
Maybe it is because of internet connection. Okay. Hopefully now it won't happen. So I think this everyone understood. DCFSZ counter comma 1. Okay. Then we need to just, now we don't need to check the condition. We need to just go back again. So we will just go to use the label again. Okay. And this will just add the numbers at number 3 this many times, that is 10 times, and store the result in working register itself, and we will end here. So let's build it. Hopefully there won't be any errors. So no errors, and build has been succeeded. So we don't have any errors. Now let's see what happens. So first you execute working register. You see here you have given D10, and in working register it is stored in hexadecimal as 0A, 0A. So next when you execute, so here you can see, let me go to the address 30. So at 30 A is stored. Okay, so this counter is nothing but is a memory location. So whenever we are specifying counter, we are specifying this memory location. Okay, So you can specify different number, you can give the name to different memory location by using this directive, that is EQU directive. Okay. So at 30, address location 30, A is stored. Now let's see what happens. Working register is cleared here. Okay. Add 3 to it. So 3 has been added to it. Then decrement counter we have told. So decrement counter, you can see 30 address location content, that is 0A, is decremented to 9. Okay. So whenever we use this decrement, next you need to specify the address. So this address is counter is nothing but 30. So at that address, whatever the content is, that gets decremented. And because we have mentioned 1, this decremented value is stored in 30. If we don't mention 1 here, this 9 will be stored in working register and not at 30. So that will create the problem. Okay. So indicate this 1 and 0 as per requirement. Okay. And because this counter value was not 0, it went to next instruction, that is go to instruction. So it will go back again. Again, it will add 3. So it became 6 and decrement. So now it's 8 here and again go back. So this will happen repeatedly until we reach 0. So now it is 0. Okay. So because it is 0, it has skipped this go to again and it went to end. So execution has been stopped. Okay. Got it. And you can see the result in working register as 1E. Okay. So this is how you need to use this decrement and increment with skip 0 or skip not 0 this way. Okay. So this way you can create the loop. Got it? Any doubts in this? Any doubts? Here you can see that working register address is also given, that is FE8. So if you want to use working register with a address, that also you can do. Actually you can specify the address and you can do that. Okay.
Decrement instruction.
Decrement, this one. Okay, decrement will actually decrement row. Let me start it again. So first we are carrying out 10 into working get register, then we are copying the 10 here. You can see 0A. This you can see, right?
Yes, sir.
Okay. So you have 0A here. Now when you add 3, then when you decrement, did 0A decremented by 1 and gave us 9. Okay. And this is 9 stored here because we have 1 here. Okay. Now is this 9 0? No, it is not 0. That's why this particular instruction didn't skip next instruction. Okay, go to instruction is not skip. It went to the go to instruction. Okay. Let me have an another instruction here. Let me store the result of our addition in 20. build it again. So result is not 0, so it will go back again to the loop. Okay, and it will do the addition for until this counter becomes 0. So let's move to that counter to 0 to 1 actually. See, now the counter is 1. That is at 30 we have 1. Let's see what happens. So it adds 3. Now when we decrement, the result will be 0, right? The result will be 0. That's why it will skip this instruction and it will go to this instruction directly. Okay. So let's see that happening. So you can see that it has skipped go to instruction and then it went to next instruction, which is move WF instruction. Okay. So that is what here decrement file register with skip 0. Okay. Skip 0 means whenever the result of this decrement is 0, it will skip next instruction and jump to the instruction after that instruction. Okay. And here we are storing the result at 25. So 25 has the result. Okay. So that is how it is done. Okay. So that's how this decrement FSZ works. And same way, if you go with increment also, it works similar way. Increment FSZ also works in similar way. That is, if it is 0, okay, then it is skipped. The thing to remember is, if you forgot to give this one here, let's say I forgot to give 1, okay, what will happen? Let's see how it will make the difference. So if you execute, so add, now let's see decrement. So here you can see that you have A at 30 and 3 at working register. Okay. So if you execute this, so still it's not making any different. Let 0. By default it is taking as 1. So let's see what happens. Here it is A and working register is 3. So when you execute, so here still there is A, and here at working register you can see you got 09. So decrement answer is stored in working register because we have 0 here. Okay, 0 means working register, so it will be automatically select as working register as the destination. So that should not happen. Okay, that's why we specify 1 here, so that the counter where the counter is stored at the location, only there the updation happens, not at the working register. Okay, I hope this made everything clear for you.
Yes, sir.
Okay, so if you have a PC or laptop at your home, try to download this MPLAB IDE version 8.91, or you can even download 8.92 also, doesn't matter. So you download one of this MPLAB IDE and then try to do this simple programs first. Okay. Slowly in our next session also we will go a little bit further and use little bit complicated programs, and we will try to understand other special function register. Today we just understood about working registers and the importance of access bit and destination bit with BSR register. Okay, but there are many other register also. uh, for example, if we want to add 10 numbers from the memory location, how we are going to add? Let's say that address at which the numbers are stored are from 20 to 29. Okay, so if you want to add it one by one, then in this method, if you are going with this method, then what happens is you need to every time change the address here at the addition. Okay, and changing address again and again will be difficult. So we need some means of pointer to actually point out address 20, and then we can just increment that pointer to go to the next location and next location and next location. So how that can be done in this PIC18, that we will see in our next lectures. And we'll also look into other registers also, like status register haven't looked into. Okay, that is our flags. So here we haven't took some complicated example. It was just addition of three. So naturally there won't be any carry generated. So status register is not changed here, but we'll take other numbers such that carry generates, and we'll see how, if carry generates, what happens to the status registers and all those things one by one. Okay. So we'll stop here for today. If you have any doubts, do ask. If not, then we'll stop here for today. Any doubts? Okay, if you don't have any doubts, then you can give your attendance and you can leave.